Okay, what we're going to take a look at today is scale drawing and models. This is from Chapter 6, Section 6. The first thing that I want to look at here is if you have, in this case here, we have 5 centimeters, okay, is equal to 2 kilometers. And that's going to be a scale that'll be given. That'll be given in the problem. It'll say something like, 5 centimeters equals 2 kilometers. And then students are to fill in a chart where they're going to be given the centimeters and they got to find the kilometers, or they'll be given the kilometers and they got to find what that would represent in centimeters. So in this case here I have this set up, and the one thing I want to point out, okay, is here's the scale given, okay, is centimeters needs to be set up proportionally right across from centimeters. Kilometers then would be set up across from kilometers. In this situation here, we're solving for how many kilometers is 10 centimeters, if this is the scale. All right, so what we do is we cross multiply. Okay, and we've done this before. Okay, so 2 times 10 is 20, that would go here. We're solving for this. I'll put x in there, so we would have 5x when we cross here. Okay, and then we solve for x. So to get rid of this 5, we divide both sides by 5, and I'm allowing students now to use a shortcut to get to the answer, so we can multiply and then divide by this number to get there. So x, in this case, is going to equal 4. Okay, so, and this would be kilometers, so it should be labeled like that. Now, here's one using the same scale, 5 centimeters equals 2 kilometers, and we're given 10 kilometers here. We got to find out how many centimeters would that be on a map or whatever. So same idea here. I'm going to put a variable in. I'll put x in. We cross multiply. So 2 times x. Okay, we cross here. Okay, 10 times 5 is 50. Okay, so 2x equals 50. So if we divide both sides by 2, that'll get rid of this 2. So x is going to equal 25 here. Okay, so this answer is 25. I can put it right here. Okay, and once again, that was in centimeters. Okay, so that's how those are set up. Let's take a look at a similar one. Okay, here's one now where the scale given is 1/4 inch equals 2 feet. Okay, so we set it up as a fraction. 1/4 inch equals 2 feet. Now, I don't want to deal with this 1/4 all the time, okay? This particular problem is that there's a chart, and students have to fill the chart in. So they have about 10 problems to do using this. So my suggestion would be, instead of having to deal with this 1/4, let's write an equal proportion to 1/4 inch equals 2 feet. And that would be multiplying both the numerator and denominator, in this case, by 4. Okay, there's 4 1/4 in an inch. Right, so 4 times 1/4 gives you 1, and 4 times 2 gives you 8. So this right here would be a little easier to work with. So I would convert that to this and go from here. Okay, now in this particular problem, they want to know, okay, if it's 16 feet, how many inches would that show on the model, on a scale drawing or something like that. So once again, we do the cross product. 16 times 1 is 16. 8 times, say, x here is going to be 8x. All right, and now we solve for x. Okay, and we divide both sides by 8, so x is going to equal 2. In this case, inches. All right, fast way to do this one, since 8 evenly goes into 16, you could go 2 times 8 is 16, 2 times 1 is 2. You wouldn't have to do all that work, but anyway, here's another one. Now this time we got a decimal amount. We have the inches, and we want to find the actual amount, how many feet it would be. This is off of the scale drawing. Now we're finding the actual amount in feet. So once again, we cross multiply. Okay, 8 times 1.25 is going to be 8, 9, that's going to be 10, I believe. Okay, and if we put an x in here, we get 1x, which is just x, so x in this case equals 10. Okay, and it would be feet. All right? So that's a little easier than dealing with this 1/4 each time, which students could type in using a calculator or change the 1/4 to a fraction or to a decimal, 0.25. But I like the idea of changing it to 1 inch equals 8 feet and using that. Okay, now here's another type of problem that sometimes we're going to see during this section, and that is writing scale factor. Okay, and I got a little note here, scale factor has the same units. Okay, unlike the problems we just saw, those had different units. One was centimeters to kilometers or kilometers. The other one was inches and feet. So in this case here, if you have a problem like this where it's 10 inches equals 1 foot, well, we got to write the scale factor. Okay, they want the scale factor. This, we can't just put it like this and say that's scale factor, because it's not scale factor. This is the scale, but not scale factor. We need to have the same units. So I'm going to change 1 foot to 12 inches. Okay, now when we write this, okay, we have the same units. Okay, so now I could think of it like this, and it's generally written in fraction form. I could put it like that, okay, 10 over 12, or we could find the value 1 inch equals how many inches using this. If I went like this here and put a 1 here, all right, and cross product it, okay, I'm going to get 12, okay, here, and if I put an x here, x times 10 is 10x. Okay, and now solve divided both by 10. Okay, it's going to end up being, what, 1.2, I think. So 1.2 inches. So another way to write this would be 1 over 1.2 would be another scale factor for this. But, you know, this would be probably good enough to just put it just like this. But the key to scale factor is you have to have the same units and then write it in fraction form. Whether you want to put it in reduced form, you can put it out 5 over 6, that would be another way this answer could be given. These would actually probably be 2 better ways to put the answer than this right here. I don't like really a decimal in a fraction if it can be avoided and taken out. Anyway, either of these 2 would probably be the best way to put it. Alright, hopefully this is helpful. Once again, this was for Chapter 6, Section 6.